Welcome to our second debate. My name is Maida Saboya. I'm a postdoc at the Valley Institute of Technology, and I will be co-hosting this debate with Sylvia.
Hello, I'm Sylvia Herbert from UC San Diego. We are moving towards the ubiquity of autonomous robots operating in our everyday life. However, ensuring that these systems act safely is an immense challenge. Introducing complex systems into real-world, uncertain environments while guaranteeing safety at all times may be impossible in applications like self-driving vehicles, collaborative factory robots, and assistive robots. In our second debate, we would like to question whether or not the pace, the safety standards, and regulations surrounding the current deployment of these systems are adequate. More specifically, our second debate considers the following resolution. The development of high-stakes autonomous systems warrants taking significant risks with real-world deployment to accelerate progress. And before we begin our debate, please go to the Slido and vote on whether you agree.
Now let's introduce the debaters. To argue in favor of this resolution, we have Dr. Raman. She's a roboticist, currently working at Zipline, developing planning methods for a fleet of drones to autonomously deliver life-saving medical supplies in remote regions of Rwanda and Ghana. She previously had positions at Neuro, Zoox, United Technology Research Center, and Caltech. She holds a position. She holds a PhD in computer science from Cornell University and a bachelor's degree in math and computer science from Wesley College. Her specialization is in formal methods and planning for autonomous systems. Join Dr. Vasu, we have Professor Gillian Hadfield. She's a Schwarzer Raman Chair in Technology and Society, Professor of Law and Professor of Strategic Management at the University of Toronto. She's a Senior Policy Advisor for OpenAI and an advisor to several organizations and technology companies engaged in innovating new ways to make law and policy smarter, more accessible, and more responsive to technology and artificial intelligence.
Against, we have Professor Kristi Morgansen, who is the chair of the Department of Aeronautics and Astronautics at the University of Washington. Professor Morgansen's group works at the intersection of engineering, biology, and computer science to study and translate the fundamental scientific properties of biological flight to engineered flight. She applies this research of biological systems to advance agile, high-performance network autonomous systems for air, space, land, and water environments. These nonlinear systems integrate sensing and actuation, stability and robustness in switched nonlinear systems, and with delay and operational constraints such as communication delays and control of multi-vehicle systems. On the against team, we also have Maynard Holliday, who has just been appointed by the Biden-Harris administration as the Director of Research and Engineering for Defense Modernization at the Pentagon. So many congratulations are in order. His background ranges across robotics startups in Silicon Valley, managing large-scale projects at Lawrence Livermore and Sandia National Labs, and working as a senior engineer at Rand Corporation. In 2014, he was appointed by President Obama as the Senior Technical Advisor to the U.S. Undersecretary of Defense for Acquisition Technology and Logistics.
Finally, we are glad to have Ryan Gariepy as our moderator. He is the Chief Technology Officer and co-founder of Clearpath Robotics and Automotors. He's also on the board of directors of the Open Source Robotics Foundation. He has completed a master's degree in mechanical engineering and a bachelor's degree in mechatronic engineering, both at University of Waterloo. Now I invite you, Ryan, to moderate our second debate. Thank you.
Thank you, everyone, for the introductions, and thank you very much for the participants and, of course, the audience. Just to provide some personal commentary, this topic is very near and dear to my heart. If you're developing an autonomous system, like it or not, you will have to make a decision on where your operating point will be when it comes to balancing taking risks against making progress. These decisions are happening every day, and they guide how thousands of person hours and billions of dollars are spent per year in this field. So with that, we're putting it on the table that the development of high-stakes autonomous systems warrants taking significant risks with real-world deployment to accelerate progress. We'll start with Professor Hadfield to lead off the fours side of this.
Thank you, Ryan. I'm really looking forward to this. Welcome, everybody. And thanks for the opportunity to convince you all of the wisdom of the proposition that the development of high-stakes autonomous systems warrants taking significant risks with real-world deployment to accelerate progress. My academic expertise is in economics and law. So I'm going to be focusing on the wisdom of the proposition as a matter of the real world of trade-offs that are inherent in promoting the welfare-enhancing innovations and regulating to make sure that those innovations do not cause undue harm. And my debating partner, Vasu, will talk about the real world of engineering and her experience in innovation and dealing with regulators. So the central wisdom of this proposition is found in this concept of trade-off. Our claim is that if you reject this proposition, you're engaging in a form of magical thinking, that we can have the benefits of substantial innovation in AI and robotics without taking any risks. We think that's misguided, at least. All innovation and economic development takes risk-taking, and it's also misguided to interpret the proposition to mean risks be damned. Taking significant risk does not mean taking unbounded or unwarranted risk. Our argument will boil down to this: significant benefits warrant significant risks. So there's 4 key points I want to open with. Number 1, we should do as much as we can with simulation and lab experiments, but economies and societies are complex adaptive systems, meaning that they are composed of a huge number of independent agents making decisions in response to each other in what biologists call a dancing landscape. There is much that is unpredictable in all the ways that these components interact. And we do not have and are unlikely to be able to produce full simulations of human systems and behavior. There's therefore much that we will not be able to learn, there's very much we will not be able to learn without real world deployment. And that means if you reject this proposition, then we are saying that we can never deploy such systems. If we want self-driving cars, we will need real world deployment in some fashion to develop them. Point number 2, some high stakes autonomous systems will offer significant, perhaps very large benefits relative to the systems now in place. Suppose we develop an autonomous system that, if it works, could reverse climate change, for example, or drastically reduce the incidence of fatal disease in poor countries with non-existent healthcare public systems. If you reject the proposition, that means that you irrationally are choosing a worse status quo over a promising alternative. Point number 3, the key phrase in the proposition is significant risk, not unlimited or exorbitant risk. Risks can be significant and still warranted. Our goal should be to design regulatory and oversight systems that are good at predicting risk and overseeing deployment to minimize risk. If we deploy autonomous systems in immigration and migration adjudication systems, for example, which are high stakes for the people involved, we can do so and should do so in well-monitored and audited regimes that track errors and correct them as much as possible. There will be significant risk of error when first deployed, but the human cost of our current schemes is very high too. We can design smart approaches. Last point. The error is leaving it up to AI developers to decide what risks to take, as they do in many cases now. Deploying, for example, recommender systems that it turns out are high stakes because they have proven capable of undermining democratic institutions and fostering violence. We need to take significant risks to achieve the benefits of AI, but we have to do that. We need to focus much more attention on how we will build those appropriate regulatory regimes to ensure that the risks we take are calibrated and ultimately under democratic and not corporate control. And I firmly believe that we can do that. And that's what I'm working on with my colleagues at the Schwartz Reese Institute for Technology and Society at the University of Toronto. And for that reason, you should vote in favor of that proposition.
Thank you very much, Professor Hadfield. Let's move on to the first opening statement of the against side, which will be given by Professor Morgansen.
Thank you so much. And I'm very happy to be here to provide some context and a different opinion on this platform, on this question. I think it's very important that we actually vote against this plan. It is not a well-founded idea and it will not lead us to a positive outcome. So first, my experience, I work in guidance, navigation, and control for autonomous systems, underwater, air, and space. I work both in theory and in hardware validation, from benchtop prototype all the way through to commercial systems. I am a faculty member and a chair of an aerospace engineering department, and I teach design to undergraduates and graduate students. So for some context on the statement, I think this is very important that we clarify some of the language. So first of all, high stakes autonomous systems. These are systems for which improper behavior would cause likely harm to human life, catastrophic environmental damage, economic collapse, or a similar scale of negative outcomes. Significant risks. Either the operation is happening intentionally while not all known risks are being mitigated to a reasonable level. Actions must be taken in a time frame which does not allow appropriate risk mitigation planning, or reasonable risk mitigation is not economically or physically reasonable. And then real world deployment. Operating in an environment with natural time and spatial scales that cannot be controlled is dynamic and stochastic, sensing that may be messy. Models are highly complex with large unknowns. Okay, so my points in particular, and I have, I think, 4 of these. So discipline and rigor. One should always take a disciplined approach to handling, containing, and mitigating risk. The approach can and should be staged to incorporate safety. Properly defined key performance indicators with verification and validation provide a tried and true structure for achieving design goals in a safety critical system. Even some of our currently highly accelerated programs, for example, the SpaceX Dragon capsule, have engaged a repetitive design build test cycle that embraces failures as a learning mechanism without leading to endangering human life. Thorough understanding to reach the best solution requires thorough assessment, not quick cowboy approaches. Education and training. One of the points of training people as engineers and scientists is that analysis-based design with rigor accelerates the design cycle as compared to design that is strictly intuition-based and experiential. Encouraging proper assessment of necessary resources such as workforce scope, training, and risk awareness, and planning to provide these resources is a key step to mitigating risk. We have a responsibility as educators, scientists, and engineers to not promote bad planning. Public opinion. An important point to be aware of is that risk of fallout from high-stakes systems in the real world is extreme. Loss of support from the general public, the taxpayers providing funding for much of basic research, another AI winter, economic recession, failure of key commercial entities from safety failures are a huge concern. Further, the faces of the people doing high-risk work matter. Failures in high-risk systems have broader impacts on the careers and perception of persons from underrepresented demographics than persons in the majority, which leads to more entrenched disparities. And finally, administrative costs. Have you perhaps noticed the increasing costs and staffing associated with liability management? Have you ever noticed that new rules follow demonstrations of Darwinism? The costs associated with high liability situations, or just those with excessive accidents, can be prohibitive to any progress and completely outweigh the possible gains of accelerated technical development through high-risk options. Thank you.
Thank you very much. And let's move on to another perspective from the fours given by Vasu.
Hi, everyone. It's great to be here. Great to see a lot of familiar faces. So as Gillian said, I'm going to be speaking from my experience as a robotics researcher and engineer trying to deploy these high-stakes autonomous systems in the real world. I'm going to say before I begin that my opinions today are informed by my experience and not endorsed by anyone who pays me or has paid me in the past. So it's all me. You can blame me. So I think that we can all agree that many high-stakes autonomous systems hold this potential that Gillian described for significant benefits. For example, self-driving cars promise to eliminate hundreds of thousands of accidental human deaths a year globally, and I think it's tens of thousands in the US, sort of high tens of thousands in the US. And also to, in the long run, stop climate change, maybe even reverse it. At Zipline, we're working to eliminate scarcity in healthcare via drone-powered logistics, literally trying to save lives by delivering timely blood, medicine, and vaccines. And so these are the stakes we're talking about, right? So imagine a world where we could have that. That's what we're arguing in favor of here. So to prepare these technologies for deployment, We should obviously test and de-risk as much as we can with simulation, controlled experiments, test facilities, that sort of thing. And it's not like we're not doing that, right? Companies today spend millions of dollars a year on testing, whether in the cloud or at physical test sites. But there's a lot we just won't be able to learn without real-world deployment. Now, we talk a lot about unknown unknowns, and the real world is full of unknown unknowns, right? So V0 of a product is never perfect. When the rubber meets the road, there's usually friction, release early, release often. Yeah, I know I sound like a Silicon Valley cliche, but it's all true when you're trying to actually do something and have an impact. So working with regulators for permits, to get permits for things like real-world deployment and even sometimes just real-world testing, currently takes a lot of process and time and can lead to frustration because the starting point is often, well, we don't have regulations in place for your robots, so you can't operate them legally. So everything you do is illegal. And when did that happen, right? The first motor car was invented and sort of released on public roads in 1886. But meanwhile, the first law governing them was passed 15 years later in 1901, right? So what were they doing in that time? They were innovating and discovering sort of that technology. Another really nice story I like is that the federal role in aviation safety began not initially as an industry regulator, but rather as sort of the operator of the US Air Mail Service. And it turned out that they were basically so safe in that service that the rest of the aviation industry started begging them for safety oversight, like, oh, tell us your ways, right? So that's sort of where we're coming from. And where we are today is a bit different, right? But the good news is that most regulators are beginning to identify and prioritize the benefits of this autonomous technology. But to sort of really accelerate progress, there needs to be a close partnership between regulatory bodies and autonomy engineering and product teams in order to determine sort of what risk is considered acceptable, how it's reevaluated over time as the technology progresses and proves its benefits. And it sometimes feels like folks on either side of this divide speak very different languages and don't really think about or assess risk in the same frameworks. And that's what needs to change. And there's sort of a couple of aspects to this I see as key. Those of us working on building and testing these systems need to sort of clearly identify the gaps in simulation and testing that a real world deployment would fill. We will see things we don't even know are problems today is not an argument that inspires trust with regulators, even if it's the most compelling argument from an engineering perspective. Also, as Gillian alluded to, it's really important to note that we're not talking about taking on arbitrary risk. We need to be able to sort of foresee the risks that we are taking on, take them on consciously, and monitor deployments to make sure that any unforeseen risks are quickly identified and mitigated. This calls for sort of risk quantification and monitoring that technologists and regulators can agree on, but also explicit trade-offs between the societal benefit of a technology and the incremental risk incurred by expanding the scope. Okay, great. So the last thing I'll say is, one point is that close partnership like this is required because otherwise you end up with risk-related metrics that can fall prey to Goodhart's law, which says that when a measure becomes a target, it ceases to be good. And we've seen this in the past. And so, I think calculated risk we take on together is the way forward.
Thank you, Vasu. And we did have a citation of Goodhart's law in the previous debate. Let's move on to Maynard's position to close off the opening arguments. Take it away.
All right, thanks everyone. So I'm Maynard Holliday, and I'm going to be, the views expressed by me today are my own and are not necessarily the views of the Department of Defense or the US government. So I want to make that clear up front. So, we're at a critical juncture in the development of high stakes autonomous systems where much has been promised and much has been achieved, but large scale real world deployment is still on the distant horizon. I believe the robotics community has a finite number of chances to engender public trust to set the stage for widespread public adoption of high stakes autonomous systems. Decisions we make now will color public perceptions for years to come. As to the safety and reliability of high stakes autonomous systems, so we have to get it right for there to be a path to widespread deployment and adoption of these systems. So significant risks in my mind, introducing systems in the wild, i.e. into the public without their consent or knowledge and hoping for the best is a recipe for disaster. And so let's put some names to this. So this practice directly led to the tragic death of Elaine Herzberg in Arizona in 2018 during testing of Uber's self-driving fleet. Another point of contention is Tesla's sometimes, depending on who you talk to, misleading labeling of its level 2 driver assist system as autopilot. And we all know level 2 requires the full attention of the driver. And so what we've seen though, with the deployment in the public, is that this misplaced confidence and willful disregard in following safety instructions as outlined by Tesla has led to some very high profile crashes where owners did not fully comply with the supervisory control required for these systems to operate safely. And that has led to injuries and death. And so much less publicized small drone collisions and near misses with passenger aircraft and helicopters worldwide are also emblematic of a problem of high stakes autonomous systems that could cause irreparable harm to the unsuspecting public. So, so just an aside, autonomy at rest, i.e. tool AI like Siri, Alexa, and sentencing tools like Compass, the correctional offender management profiling for alternative sanction is another related issue that also needs to be addressed, in another forum. So I posit that to make demonstrable progress in fielding high stakes autonomous systems, all stakeholders, public and private, need to be involved in any public deployment plans. An AV version of FDA drug trials is in order, where town, retirement community, or any geographically designated area all agree to be part of a deployment pilot. So where there are mutually agreed upon rules of the road, like operating times, operational areas, acceptable weather conditions, and then plans to mitigate potential accidents with indigent populations, and many more potential corner cases. So currently, that's not done. So if something like this approach isn't done, wider acceptance of high stakes AI will never happen outside of technology-friendly coastal area, urban centers, and it will defeat the promise, that we all know that AVs have in minimizing road deaths due to human error. Thank you.
Thank you very much, everyone. And just a reminder that the Q&A is open at Slido, and we're seeing some questions come in right now. So I'll just take from the top here. This question from the anonymous member of the audience. When we take significant risks with high stakes autonomous systems, who has the power to take these risks? And who bears the brunt of the consequences of these risks? Would anyone from the fours like to start by addressing this?
I'm happy to do so. Vasu, you want to say something?
Go for it.
Okay, all right. So so one of the points in my opening was to say this is a really important question. Who decides on what the appropriate risks are? And this is why what I'm emphasizing is, we are seeing a lot of those risks and those risk decisions being made within corporations and within the companies that are building technologies. And we're not seeing oversight from the democratically controlled regulatory systems that we have in place. So our claim is not that we have all the existing infrastructure that we need in order to be able to do these deployments, but that we should be doing that. The question about the risk should be within a risk management system that's ultimately responsible to democratic government. Who's affected by the risk? Well, there's a lot of people. That's part of the point. Vasu emphasized a lot of unknowns, and I totally agree with the points made by I think it was Kristi who emphasized this, and Maynard you may have as well, that people affected will often be the most vulnerable in our populations and communities, and it is quite critical that we have oversight of those risks. We just don't believe that means that you don't ultimately end up in some real world deployments taking significant risk as appropriate.
All right, and just to maybe another 30 seconds, how do you combine the need that you still need to take significant risks with a extensive risk management practice? They may seem to some to be in conflict.
But we take risks all the time. We take risks with drugs, we take risks with vaccines, we take risks with the design of highways, we take risks with current existing cars. I mean, the world is filled with risk, and most of the products that we sell, the services we offer, there's risk inherent in them. So it's, those risks are there. What you want, and Vasu emphasized this, you want systems that monitor. So we need to develop metrics to assess risk. We need to develop those risk frameworks, and we need to put in place regular auditing practices. We don't tend to do that now. We tend to, look at risks up front and then put things out there. And then we rely on things like the tort system for people to sue when there's been a risk that we've discovered. I think we want smarter approaches than that. But we have lots of ways of evaluating this. You can audit for accident rates. You can audit for intrusions. You can audit for the kind of harms that we're worried about. And I think we should be explicitly measuring that.
All right. And would a member of the, would a member of the against like to speak to that point on the, who gets to make these decisions?
Yeah, I would. I'd just like to push back, all the risks, that Gillian speaks of all have a regime up front to determine whether it's safe for the public to interact, with systems. And so there's no equivalent currently for the deployment of autonomous vehicles. So some would posit that California's regulation on disengagements, that just counted disengagements was one attempt, and people in the space know that that was an ineffective measure of safety. So I would say that before drugs hit the market, they're tested. Before vaccines hit the market, they're tested. Before you fly in an airplane, it's certified. And so, before a teenager gets a license, he or she has to take a test. And so, there needs to be a regime in place to ensure safety of these systems before they hit the wild. Thank you.
Just because we've just to keep things a little balanced here, is there anything you'd like to say, Kristi?
I completely agree with Maynard. I will just reiterate, we must have a risk assessment system in place and training for people to use it before we set things loose. I will note we have an IRB process that, like, if you want to write a journal paper about students taking a test, you have to get it cleared through an IRB process. And yet we don't do that with, testing in the wild with the general public. And I think that's a mistake.
So that's interesting. That actually touches on one of the next questions, which is actually at the top of the list here from Alex Raymond. And it makes the analogy to pharmacological research, which we're very, very familiar. I think all of us have become de facto armchair experts in clinical trials in the last year. But due to risks to humans, pharmacological research gradually progresses from controlled environments to realistic human trials. And only after demonstrating high levels of safety in those, I assume, can proceed. Oh, sorry, that is my timer. Anyway, why should it be different for robotics research?
I can go. I don't think it's necessarily different in spirit, right? So we're still talking about doing, millions of hours of simulation testing and flight testing prior to a real world deployment. The timescales for pharmaceutical research have also accelerated recently. Like the COVID vaccine is a great example where because of the massive impact and the massive potential, I think that regulators were willing to work with companies on a safe way to bring that to fruition quicker than it might have in a non-emergent situation. And so I think that in spirit, it's not that different from the way we take on risk in those scenarios. One thing that I want to emphasize is it's probably a good idea for the risk to be taken on, as with clinical trials, by the people who stand the most to benefit from the technology, right? So if you're going to do a deployment, it should be with the buy-in of either the folks who stand to benefit or their representatives, ideally both, because one is the other. Sometimes not the case, but yeah. So that's all I have on that for now.
Thanks. Anything to note as well, Gillian?
No, I think I'll leave the robotics to Vasu.
All right, sounds great. How about on the against side? What do you have to say about this analogy?
I will say, I think it's a great analogy. You know, one of the things that we actually lack with AI systems is that system of staged testing. Like, we haven't honestly come up with those benchmarks. And I think we really need to do that if we want to convince the public that they're safe with these systems. This is a study of a lot of research. And I'll point out one of the key problems with this. You know, there's been a good deal of interest lately in verification of published results. And there's some great studies out there showing how many published results have not been replicable by others. And I think that we must fix that problem, which is the risk mitigation, which means you're lowering the risk and it's not so high stakes then. That's the whole point. So.
Maynard, anything to add?
Nope.
All right. Just one note here. I mean, we're very early on in the debate, and I think we're starting to agree with each other a little bit more than we should. So I just like to call this back. Like, we all know that risk assessments are an important thing, but we're really talking about, you know, progress and significant risks. So let's make sure that we are continuing to do this, right? Like, you know, when push comes to shove, do we throw the risk assessments out the window? Do we test in front of do we test with people who may not have consented, right? Because we do see companies and researchers doing this. Conversely, do we hold back? Do we be the robotics equivalent of the older car companies when the EVs came knocking? Do we not do anything for 10 years, right? Like, let's make sure that we are exploring the extremes of this argument, right? We all know risk assessments are a thing. I think we all agree with that point, but, you know, let's take some of these extremes here. You know, so I'll pick another one. I'll pick another one off the list. The for side talks about autonomous systems as a panacea for the world's problems. How must we consider these technologies' risks in comparison to less fashionable, non-technical solutions that are effective and less risky? Oh, let's switch it up. I'll lead with the againsts.
Can you repeat that question? I'm sorry, I didn't quite.
Okay. The for side talks about autonomous systems as a panacea for the world's problems. How must we consider these technologies' risks in comparison to less fashionable, non-technical solutions that are effective and less risky?
Yeah, I think I'm actually still a little bit confused about what solutions they're talking about, but
to provide an example, which I would, if I'm just thinking off the top of my head, the example would be, and AVs being a popular one here, the counterpoint would be, why develop on-road autonomous, like level 5 cars? Why push towards level 5? Why push towards hands-off when you could spend time and effort working on, you know, ADAS systems, or for that matter, better public transit?
Oh. Yeah.
Just as an example of, you know, parallel solutions to the same fundamental problem.
Yeah, I think that's a very valid point. I mean, you know, if we're going to be weighing the options, you know, I think there needs to be a broader context. And I think this is something that we would really benefit from, which is take it in a much broader cost assessment. So, and take into account some metrics around, you know, like with the public transit option, you know, perhaps that's going to be better because we are saving fuel. That might be a greener solution, which is, you know, something to be considered. Maynard?
Yeah, so I'm in agreement, but as a technologist and a roboticist, out here in the Valley, technology companies do things because they can, right? Simply because the capability is there. They say, let's try it and see what the results are, and we've seen the results of things being deployed in the wild, and people's overconfidence in mislabeled systems, and not following instructions. So that needs to be considered. And a point I'd like to make is none of kind of the indigent populations and marginalized populations are considered in these programs until the government and the public says look, because you can look at the scooter deployments in San Francisco about 2 years ago, and how they were not equitably distributed amongst the neighborhoods, and that was a corporate decision, because that's not where the they thought the return was. So anyway, so there needs to be a holistic view of these deployments, and to make them more equitable.
All right, and I assume it's implied there that with such a holistic view, the significant risks would be decreased.
Yes.
Okay. Now the counterpoint. You know what? Doesn't matter what a bus is in ADAS systems. Level 5 is the long-term benefit to society. Let's do that at all costs.
I could go first.
Go for it.
I don't think that's the argument at all, right? Like, why not both? I feel that saying that just because you're working on a level 5 system doesn't mean you don't take public transport is both myopic and sort of not ambitious enough. I think we should be doing all of these things to better our current situation, which is that the planet is going to die a fiery death. But yeah, the other main thing I'll point out is, many things in human history, many awesome things have happened because someone said, can I do that? I think I can. Let me try, right? And so why would we give up these big step function changes in our human capability and sort of limp towards something we may never actually be able to achieve? And that's the question I pose to the against side. Like, why would we continue the way that hasn't been working when we have this opportunity to effect massive change, and all that we need to do is figure out how much risk we're willing to take?
Anything to add on top of that before I'll actually give the against side time to respond on this particular question? But Gillian, any other questions for the against side?
Yes. I don't know how any roboticist can argue against this proposition unless you're planning on giving up your funding and shifting your work. If you're focusing on building autonomous systems, presumably you're interested in building things that have really significant benefit for the world. That's what we're focused on. If you don't think that there are those big benefits available, then we are tinkering. And okay, we should be looking at, we should be doing all these other things as well. And I think that you don't want to, in thinking about this proposition, you don't want to be attracted to kind of the straw man arguments. Oh, on more, wild risk, cowboy risk. Sorry, Kristi. Just like far beyond, it's not about that. It's about, and one of my points to lead with was we have not yet developed the regulatory structures that we need to manage those risks well. But I think the core of the proposition, and it's right to push on this, Ryan, otherwise it sounds like pablum, there are real differences around the world. The EU has introduced a framework for regulating AI. And Vasu referenced, sort of the headwinds and so on our existing regulatory processes. they are going to significantly slow progress because we don't have those proper regulatory structures in place. I mean, I could go on for a long time about how I think you build those proper regulatory structures. But I think at the end of the day, you have to recognize you can't do the deployment, you can't learn everything from the lab and simulations. You're going to have real world deployments. And at the end of the day, that will always involve some residual significant risk. But the world is full of risks, and we take risks all the time. And there are tremendous risks in the way the world is now. Vasu, you know, if she wants to say more about Zipline, right? It's not like there's no risk sitting out there, right? It's in the absence of the system, there's death.
Thank you. And just before the against respond here, I will note we're running out of time on the moderated discussion portion. So before we move to closing remarks, there's a lot of questions still on Slido. Please go in and vote, because we've only got time probably to take one more. So with that note, Maynard and Kristi, I believe, Kristi's responding.
Oh, I'm on it. Okay, so this is exactly my point. We have backed ourselves into a whole bunch of corners because we didn't stop for a moment and say, let's stop and think about where could the risks be here? And are we asking all the right questions about those risks? That's what makes it significant risk. Absolutely, we're all at risk. I mean, one of the planes flying overhead right now could fall on my house. That's a risk. We accept that by letting people fly. But we have all kinds of problems, like there are articles around how many drones are being flown near commercial aircraft at airports because there's no way of the aircraft, like there's no plan to say, like, you can't do that, and some way of making it stop. And there's no training of people to reinforce that in the general public. So there's this whole mess around how do we build these novel, amazing systems and make them functional and accepted and be able to have these novel solutions at the same time, doing it in a way that will be accepted and doesn't stick into the corner a bunch of things that could have been awesome, but somebody didn't follow their safety plan and hurt someone. And now we're just never going to touch that thing again. That's the problem. You're actually losing solutions by taking on way too much risk without planning for it.
Okay. Thank you. Maynard.
Yeah, so there are examples of us, getting, taking, risks and putting technology out there, and having a public backlash. And so if we deploy and we've all seen this, every accident that Tesla is in is a national news story, as opposed to all the accidents that happen with internal combustion engine cars. And so we need to come to a point where how safe is safe enough, and what is the deployment risk, and so I would point people to supersonic air transport, right? That was never approved in the US because of the environmental issues around sonic booms over land, and so eventually we have no supersonic transport now, because of these these issues were not dealt with, and we went ahead deployed, but no US carrier adopted it. And so we're going to have a similar issue if we continue to deploy in the wild and incur injuries and death without a regulatory regime that that mitigates this and gives the public confidence in these systems.
Thank you. Unfortunately, that we're tied for two top questions here. I'm going to note there's one about how do technical progress spurred by military development, and how do we avoid offloading these risks onto foreign populations. I'll note that is a bit of a refinement of some of the earlier questions about generally how do you consent to being parts of the test. So I think it's a very valid question. And I know that Maynard and I also participate in some other discussions on that point, among others. So with that, we'll just jump to take one more question here from the audience. No, that's the one. Okay, so how do we avoid offloading our risks onto foreign populations by developing this? Let's go 30 seconds. Who's for the force?
I think I already alluded to my opinion on this, which is that it should be whoever stands to benefit that takes on the risk. So I'll let Gillian elaborate if she has more.
Yeah, I'm out of my depth on the military ones here, especially with Maynard on the call, I guess, and others who've worked in this domain. I think Vazu's right. It's those that enjoy the benefits. You have to think about are these corporate developments, are they private sector developments, or are they government developments? The government one is about treaties and foreign relations. I think the foreign populations. Well, I don't even know how to think about who we're thinking about as foreign populations. So I think that's the military. I'm not doing a good job on this one. I'm going to shut up.
All right, Maynard, do you want to take us home on this portion of the debate?
Just that you run the risk. When you are deploying these systems. To alienate the populations that they are interacting with, and in wartime we've already seen the use of drones in recent conflicts, so there's a asymmetry there with respect to capabilities, where one side has more capable and systems, and then they deploy them against their adversaries, and then the whole community is tainted, saying that these were bad systems, and we don't want to see them in our airspace, and so as Professor Morgansen said, we need more controls around their operational capabilities, so that there are no-fly zones and other things that protect civilian populations.
All right, thank you. And just everyone, the poll has gone up, but please don't vote yet. We do have the closing remarks. So let's start with let's do the closing remarks in the same order of the opening remarks, with Professor Hadfield, please.
Thank you very much, Ryan. Okay, so I want to come back to our key opening points. Again, significant benefits warrant taking significant risks. Our opponents have tried to paint a picture of recklessness, but we're not advocating for recklessness and no quick cowboy approaches. I think that's a straw argument, as I said before. Taking significant risks is warranted, and we need innovative and democratically controlled regulatory regimes to oversee and monitor those risks. It's also important not to let our opponents change the proposition. We are not arguing about whether large-scale deployments should occur out of the gate. Smaller scale pilots, which I think Maynard actually talked about as well, are a smarter approach and a way of making sure that only warranted risks are taken. Our proposition, again, is whether to take significant risks, not wild or large-scale risks. And our opponents have also tried to persuade you to agree with them by emphasizing that high-stakes settings impose real risks on real people. In the extreme, people may die. And we don't deny those facts. But this brings us back to magical thinking. We take real risks, and real people suffer real consequences all the time. We allow people to drive cars knowing that thousands will be killed in road traffic accidents. As we talked about, we administer drugs and vaccines knowing that some will suffer rare, perhaps deadly side effects, even after all of the, as Maynard correctly emphasized, all of the pre-testing we do and the evaluations and clinical trials and so on. We rely on humans to decide criminal sentencing and bail, knowing that sometimes these people will be corrupt, lazy, biased, and cruel. And we do these things not because they're harmless, but because done properly, they systematically produce more benefit than harm. We work hard to reduce those harms, and we call them out when they happen. The effort to build autonomous systems in high-stakes settings, if and when they offer substantial benefits, should not be abandoned because we cannot develop them fully in the lab. We should regulate well, but we should take significant risk when warranted with real world deployment. You should agree with us.
All right, Professor Morgansen.
Okay, so I'm going to go back to the language as well. The statement is high stakes autonomous systems warrants taking significant risks with real world deployment to accelerate progress. It's all about the context of that statement. The fact that we're even saying significant risks in a real world deployment means that you haven't taken the appropriate steps to mitigate the risk. It shouldn't be necessary if you take the appropriate steps to have significant risk. You need to engage all of the populations to make sure you have a clear assessment of what is going on. We need to have a training system, which honestly is not very well in place at this point for autonomous systems, to enforce this thoughtful process of risk mitigation so that we can actually change this statement to say that we're going to have high, not even high stakes, but high capability autonomous systems with high performance in real world environments, and that we can realize all these extensively sideline capabilities that we haven't been able to have yet. If we go with the way that this is phrased, we are inherently accepting that we are taking way more risk than we should, that we're not engaging with all the populations that need to be. We're not enforcing a culture of safety. And we need to veer away from that, or we will lose the public regard, we'll lose the funding, and we won't be able to solve the problems that we have. So I don't think that's something that can be argued. I think that the statement and this attitude with it is completely wrong. And we should not accept this at all. We should be absolutely opposed to it. That's all I have to say.
Thank you. Vasu.
Yeah, I think I agree with everything Gillian said. I agree with nothing Kristi said. And I think that, you know, the audience should agree with us because the other side just hasn't shown anything beyond trying to twist the terminology to paint us as cowboys, when in fact, maybe the real problem is a lack of ambition on their part and a lack of thinking about the fact that you can institute trainings, you can, you know, follow IRB process, you can have, you know, billions of hours of simulation-based validation, but when it comes down to it, you still need to know what risks you're taking with the deployment, and they are often going to be significant, no matter what you do. And denying that is only going to make the problem worse because it's like putting on blindfolds or sticking your head in the sand. There's no way around taking significant risks if you want to ever get to a real world deployment. The other thing I'll mention from earlier in the debate is this idea that people fly drones all the time around airports. Some of this is down to us not having good buy-in on restrictions and risk mitigation from the people actually intending to deploy these technologies, right? It's kind of like, if I don't really think what you're asking me to do is reasonable, I'm more likely to say, oh, this doesn't, you know, this is just this is bureaucracy. This isn't a meaningful restriction. And so that buy-in, I think, is key. You know, we talked about Goodhart's law. It's just an extension of that. And I think this conversation has made me more worried about that and about the fact that we really need to figure out how to take on risk in a way that everyone agrees with. Significant risk.
Thank you. And Maynard.
Yeah, so I say the proof is in the pudding, so to speak. You know, we have seen deployments of these systems in the wild, and their resulting accidents, injuries, deaths, and then if we look at the divestiture of by Lyft and Uber of their self-driving units, that speaks volumes to their calculation about how close they think deployment is, and so I would say it's the proof is for everybody to see that we're not there yet, and a regulatory regime needs to be established, before there is, widespread deployment. And then, on the drone question, the FAA has, put out rules, dictating, where and, these systems can be deployed, and, and they're flaunted. So, the community needs to, address that in its, technological, development. So I'll stop there, and thanks for your consideration.
Thank you very much, Maynard. The poll is open. We'll be closing that in a few minutes. Oh, there we go. Post-debate polls are now open. And otherwise, we've got more time. We've got more time to talk about what we think. There still is. I see all the Q&As disappeared, but there still is time to get some more questions in. So let's just start. We're just going to start in reverse here. What do you actually think, Maynard?
Well, actually, I'm a big fan of the technology and its promise. Because I've lost friends and family to car accidents over the years, and I wholeheartedly believe that they can successful deployment of level 3 and 4 systems can have a significant impact and save lives. But it's got to be done, with a mature regulatory regime that takes into account all stakeholders. And as I said in my opening, all stakeholders have to buy in, and have their concerns and potential vulnerabilities addressed.
All right, and Vasu.
Yeah, I mean, I think a lot of what I said, I actually believe, but some stuff that I absolutely agree with Kristi and Maynard on. The frameworks are not mature yet. The good news is there's a lot of impetus and a lot of sort of collaboration across regulatory bodies and industry partners and researchers to sort of get us there, which is really encouraging. I talked about sort of unknown unknowns. It's challenging to sort of identify your unknown unknowns, right? That's an oxymoron. But something that could be better, I think, on the side of people trying to have these real world deployments is to frame the request or frame the sort of ask in terms of what assumptions about the system we expect to validate or refute via a real world deployment. Characterizing what happens when those assumptions are violated and making sure that risk is mitigated. So not just saying, I want to drive this thing around to see what happens, but saying, here's how I've tested it. Here's what I'm not able to test. Here's what will happen if when I test this in the real world, something bad happens. Like, here's the worst thing that could happen. And I think we're not at a level of maturity yet where that conversation is happening sufficiently early and sufficiently often in the testing process.
Thank you. Kristi?
Yeah, so I'll be clear. I'm a huge fan of innovation. I love crazy stuff. Honestly, I make fish robots. So, enough said there. But I do say, as an educator, and I do teach capstone, and I see this huge, and I've dealt with a number of startup companies where there's sort of a lack of clarity around this whole, how do you do a plan with, the outcomes that you're expecting and the risk mitigation plan and the verification validation. And I think, honestly, I think that's an opportunity for our entire community and all the related ones to engage with the general public and actually train them a little bit more on what I have started referring to as like the engineering process. Like, you have a key performance indicator. How do you know you've achieved it? It's kind of like the scientific process, only, you have to do verification validation. What tests do you need to do to assess that you've achieved it or not achieved that goal? I would love to see some of that stuff kind of engaged with the K-12 communities, like around the robotics teams and stuff, because I think, if we can start getting that mental framework blasted out to everyone, it'll actually help a lot with the innovation, like have people understand, how do you assess if something is a good idea? So, I mean, I do think I am actually firmly against like taking significant risks in the real world, because I just don't think like we've done a good job with that. And, but I think we can. I think we can.
Thank you. Gillian.
Yeah, so I think actually, you know, I mean, you were finding this right. There's that we all really do agree that what the requirement here is for a regulatory framework that we don't really have in place now. And what we have instead is we have, on the one hand, yeah, a cowboy environment, because you may have nothing in place, and on the other, we have, say, you know, like the Canadian government that, you know, a friend of mine who builds autonomous marine search vehicles, she can't deploy them at all in Canada, so she can't really build them. And this is a really live question, right, between different governments about it is a live question about how much should we allow real world deployment. And so I think but I will sort of still come back to this point about significant risk, just to pick that up to say, and this is sort of the economist and sort of significant risk, we will be experiencing significant risk. And so I'm not making it up to say, and we have lots of risk out there. And if we say the test is, you have to do simulation in lab and whatever else you can do before real world deployment to eliminate significant risk, so that it's down to what's the opposite of significant, insignificant, minimal, negligible risk. We will never get to that because you just can't get to that point. And precisely because you won't be able to predict it in those ways. So I do think it will still involve significant risk, which is just different from unregulated or reckless or inappropriate. But I think I want to pick up on innovation. I'm a big believer. I just think we need as much innovation in our regulatory regimes as we're getting in our technology.
Thank you. And just before we jump back to some audience questions and discussion here, I'm going to take the opportunity I have to share my perspective on things, because I am legally responsible for hundreds, if not thousands of autonomous mobile robots that are out there roaming around untrained people in factories. And I'm actually on the side of the againsts here, despite being a startup founder. And the reason I say that is because there's an axis which is often ignored, which is the product management, like the broader operational design domain axis, which it's not necessarily I'm going to put my AV on all roads versus I'm going to put my AV in geofenced roads. It can also be the technology is not ready fundamentally yet. Let's try a completely limited design domain. And there's talks you can find where I've given on this, but we have 1.9 million hours of safe, unsupervised, autonomous operation in unstructured factories, right? And that was not taking significant risks. I will trust my life to these robots. I will lie down in front of them. And because the law of large numbers certainly is in effect, we've had to go through all the certifications, we've had to go through all the detailed engineering analysis. And it's entirely possible. And I don't consider that taking significant risks. And though it's certainly held back the progress in some ways, we're now at the point where there's now this foundation of understanding of how our systems work and how the factories work, where we can start layering on this new bits of technology. So I would actually, despite being in favor of progress in general, I mean, in 2015, we had a choice to pivot and become an on-road self-driving car company. We had that choice and we didn't take it because the significant risks were too high and there were other ways to drive progress. So I just wanted to share my position there as I said, this is near and dear to my heart, both personally and also, frankly, legally, it's near and dear to my heart. So on that note, one of the next questions here that we do have time to get to is, do we have the right technical language to involve stakeholders and regulators in conversations about significant risks? Promising a 99.99% probability of safety, so that's 5 nines, is likely too broad. Are all failures made equal? How do we do better? And I think this broadly comes into this question of how do we better engage regulators or other sorts of non-roboticists.
Can I take that a little bit? Because there were 9s in there, and that's like an aero catchphrase.
Yeah.
So I will say in aerospace, like we have to go out to 9 9s. So most people, like if you actually, and I don't know if possibly my colleague Chad Jenkins is watching this. I hope he does at some point, because we had a report that we did about like autonomy, safety, and the number of 9s. So like if you have like 1 9, so 90% safety, like if you think about that, like in terms of airplanes, that means that like 10 out of 100 of your airplane trips, how many trips did you used to take before COVID? 10 out of 100 of them are going to fail. Okay. Nobody is getting on that plane. And then if you start even walking it back, the reason we go all the way out to 9 9s is because that's what it takes for public acceptance of that level of risk. If you look at how many failures there have been in aircrafts in the last even 5 years, and how much outcry there's been about it, and I'm saying it's valid outcry, I'm not going to minimize that at all. That's what we have to have for public adoption. So if you want the technology to be adopted in the same way that Ryan was saying, you have to show that level of risk, not no risk and not extreme risk, but managed risk, that you know that there's risk and you're putting systems into place. It's the same way with the pharmacological studies and all of that. Like there are levels, and you don't get to go to the next one until you've shown that everything's okay at the first one. That's how it works. And I think that's what we need in order to really get the adoption of the innovation.
Thank you. Who's next?
Yeah, if I could. So, coming from, RAND, where we've looked, at this, extensively, I would remind everybody about, and this is, helps make Gillian's point that, in the US, we accept, over 30,000 highway fatalities, a year, mostly due to human error. And to equate, the diminution of that acceptance of, death and, just heartbreak, what is the level that's acceptable if, there's a, machine in the loop. And so, we don't know that yet, but it's a question, that we should ask ourselves, if we're willing to accept, this really high number, do we have to wait till we get to, as, Kristi just said, those 999s out there before we deploy, because, some level of deployment is going to, demonstrably, save lives. And so, so that's a question, we all have to deal with.
And that's leading into the position the Vasu and Gillian were taking through this entire direction, right? So anything that they'd want to note?
Let me jump in. So I think this question about how do we calibrate for the risk, I don't actually think I think it's dangerous to think that that's a purely technical question. Like what do we mean by significant risk? How many 9s is that? Ultimately, those are, this is why I sort of emphasize that you need to have this in a sort of ultimately in a democratic structure of some kind, like your political structure, because the trade-offs are ones that you really have to go back to your populations. And let's talk about some of our more vulnerable populations on both sides. So we, on one hand, we may not adequately account for the risks that vulnerable populations experience. On the other hand, we may be discounting, because we don't really know what their lives are like, the risks that they are incurring in the status quo. And so I think so ultimately it's a very important point about risk. Secondly, we know that we're all, even statisticians are terrible at really understanding risk, right? So we actually don't, we have all the studies that show us that people are very bad at evaluating risk and responding to small risks, both on the good side and the bad side. Think about the vaccines, which Vasu mentioned, right? Tiny incidents of some very, very rare complications, and, we don't know what we incurred as a cost of stopping those vaccinations, but that is a political decision that has to be made. The Tesla examples, those are, I can tell you this from teaching law, people are just really, really bad at evaluating a story like that, because you hear about the Pinto exploding and you just think, oh, you should never, ever allow that kind of a thing to happen. And it's just not a realistic way of thinking about risk. So we're really bad about risk. We need lots of work on this.
Vasumathi, what do you think?
Yeah, I mean, I agree with you. So I think, there's the mathematical modeling question, right? Do we know how to mathematically model risk and take into account the factors that affect risk? As engineers, we have a pretty decent idea. Regulators also have a decent idea of what they would like to see in these models. But, economists have been working for decades on modeling how humans respond to risk. And you can have a number that you produce from a really sophisticated mathematical model that incorporates all aspects of the risks of a deployment. And a human affected by that deployment could look at that number and say, what do I do with this? How do I, okay, I guess. So I think that's the gap. And I think that's what Gillian was also alluding to. It's not necessarily the technical math model of risk. It's how do you then take that and decide if it's truly acceptable to humans? And that's, I think that's still an active area of research in many fields.
And to build on that, just for the audience, safety engineering is a very real, very well-studied practice. Obviously, the closer you get to deploying in the general public, the more the aspects of public perception come into things. But in case you are interested, listening and interested, safety engineering, there's a lot of statistics, but there's actually fairly almost step-by-step, paint by numbers for this is how you generally assess your system for risk. And to use, Kristi's analogy, the requirements for industrial control systems is 6 to 7 nines. That's what our robots need to comply to from full autonomy systems. So there is this complete standard that does exist. And I think that is one of the discussions which is going forward is how much of this is really significant, taking the significant risk for progress, and how much of it is, well, frankly, there are a bunch of people who've never taken any of these courses and are still deploying, hundreds or thousands of pounds of robots on the skies and the seas and on the ground. Let's jump to one more question here. From Shreyas, the lay perception of AI and robotics is often riddled with misunderstanding, like for sharks, he notices. He compares this to the misunderstandings about sharks. Can more thorough or less sensationalist public education actually open more doors for high-risk testing? And I like this concept because I've been in the field since I was 17, and there's definitely some misunderstandings here and there.
I'll start on that. I completely agree. I was going to follow on Vasu's last statement. So there's the modeling of risk and how people just are not trained at all in that, and like the mathematics of modeling human perception. There's also, I think, a huge gap in the technology knowledge. I mean, we know this of the general population. And so what they think an autonomous system can do is not what an autonomous system can do. I mean, we've seen this with, definitely in Seattle, like at one point when I first moved here, like the police had bought a bunch of drones. I hate the word drone, actually. And they were going to use them for various surveillance things. But what the population thought they were going to do with them was completely out of the scope of what they could do. Like if they had a camera on there at the time, it was not like they were going to watch you 24/7. I mean, the batteries on the thing lasted 15 minutes. I mean, it was not what they were going to do with it. So, we have to help educate everyone so they understand what the technology is capable of. And I think that will stepwise help with the adoption of the technology and, relative to the risk, because people have a better understanding. It's for many people, it's just even further unknown. And that's just a huge gap too, I think.
What else do people think?
Go ahead, Maynard.
Oh, I was just going to say, in my domain, people think, Terminators are around the corner. And if, anybody saw the DARPA robotics challenge several years ago. That's nowhere near reality. And to Kristi's point about educating the public, I absolutely need to do that, and demo, and what the public has adopted, are getting on autonomous shuttles in urban areas, and we all take for granted, we get on elevators. There used to be elevator operators, right? But we have no problem now stepping into elevators, pushing a button, and going really fast up and down, with no human supervision. Same in these giant airports that have these people mover systems. They're all automatic, and move at high speeds, and everything's done automatically. And so some of these, and then there's systems that airports and other urban centers that are autonomous, that are wheeled, and so this kind of phased deployment of systems that are ever more and more capable is going to go a long way in public acceptance, and so that's what I think is the future.
All right, Gillian, let's close it off with you.
Yeah, sure. I mean, education's great. I'm an educator. I think, we certainly want the public to know, and having greater exposure to the positives of robots and autonomous systems is good. But I want to push back a little bit on education, because I think there's a lot. What makes people confident, what gives them confidence, is a well executed regulatory regime. Like, you don't think when you go into the restaurant, are they keeping the food at the right temperature, right? Because you have confidence if you are lucky to live in a well-developed, advanced system that has effective regulation, which, by the way, 3/4 of the world does not. That's what gives you confidence, and that's why my point usually here, if I didn't agree with my the point I was asked to argue, is that I go around saying, look, the crazy thing right now is you've got these powerful technologies, a complete regulatory vacuum for the most part. I mean, and our existing tools, our existing regulatory approaches are not going to work. They're not going to be able to keep up. And so this guy, I'm going to come back to regulatory innovation. And that's the most important thing we can do for, I think, acceptance of beneficial systems. So focus there.
Thank you.
If I can make a 30-second, 10-second point. I think I agree with everything everyone has just said. I feel there are 3 pillars here. There's the regulation, there's the actual proven safety of the technology, and then there's education and community outreach. I mean, so at Zipline, we've been really successful in Rwanda and Ghana with the first 2 first, but even to this day, after we've delivered, we've made well over 100,000 deliveries at this point, we still have regular outreach in the community. We bring local communities on site for tours, and that stuff really does help. It really helps even when the first 2 are going really well. So really, I think that this is sort of 3 legs of the stool that you need to stand on.
Thank you. All right, let's bring those let's bring the poll results up on screen if the person behind the curtain could. There we go. All right. Okay, so it looks like the undecideds generally remained about the same. That I'm just assuming that those 36 people stuck through us the entire time, and generally there was a bit of a swing towards pushing taking risks in real world deployment, which I think is it's interesting, and it certainly makes sense. And I think where we would proceed with this conversation is, as any good academic debate goes on, it's the endless discussions of the definitions of the words of significant risks, deployment, and progress. So I'm sure that there's going to be continued discussions on this. As we've said, there are thousands, if not tens of thousands of person hours of work being spent on making these decisions every year. And I think that's only going to increase. So I'd encourage everyone to continue thinking about this and I'm sure, provide feedback to the organizing team as well on how you think it went. Other than that, I'm just making one new message. Oh, that's good. Other than that, we are finished with this debate. I'd like to remind the debate team to stay on the line for a brief debriefing, if you could. And thank you as well for everybody for attending, both thank you for the organizers for holding it, and of course the panelists and attendees both. All right, have a good one.
All right, thank you everyone for joining us. And thank you to Raman, Gillian Hadfield, Kristi Morgansen, and Maynard Holliday for an engaging and thought-provoking debate. Many thanks to Ryan Gariepy for an excellent moderation of the debate. We'll now take about a 30-minute break and we'll be back on the hour at 1700 UTC. Finally, if you are interested in being part of the organizing committee, we encourage you to email us at roboticsdebates@gmail.com. All right, we'll see you all soon.